Okay, hi guys. We're going to be looking at the Mann Whitney U statistical test and the calculation. So we've so far now in these first 2 weeks of research methods looked at Wilcoxon and chi-squared. So now we're just going to be looking at the Mann Whitney and how that differs from those ones. So again, like with always, when we start looking at a new statistical test, we have to identify when it would be appropriate to justify the use of this test. So that's again referring to those three important questions that you have to ask yourself about the scenario or the experiment. So is it a difference or is it a correlation? What type of data or what level of measurement is being used? And what is the experimental design? So what I'm going to do is I'm going to ask you to pause the video, and when you pause the video I want you to dig out your choosing a stats table grid, or if you've already learned it off by heart, which is excellent, then you can already hopefully know what these criteria for a Mann Whitney U test would be. Okay. Okay, so hopefully if you've dug out that choosing a stats table test, you would find that for a Mann Whitney U test, it has to be a test of difference, it has to be using ordinal level data, and the experimental design will be independent groups. So the first two parts of the criteria is very similar to when we looked at the Wilcoxon. So the Wilcoxon test also was a test of difference and ordinal level. However, the main difference between these two tests is that for the Wilcoxon, it was a repeated measures design, so you'd get one group of participants doing both conditions or however many conditions. But for a Mann Whitney U, you would run it if you had two independent groups, so two separate groups of participants doing separate things. Okay. So I've got an example of a scenario. So a research investigation was looking into whether there was a difference between physiological arousal and the feelings of love, as previous research had suggested often the two can be mistaken. To test this, a researcher created high and low arousal by asking two groups of men to run on the spot for either 2 minutes or 15 seconds, and then the men were shown a short video of a young woman. Participants were asked to rate the young woman's attractiveness on a scale of 1 to 10. Group A had 10 participants and Group B had 14 participants. So what I'd like you to do first is to again pause the video and read back through that again and find out what the independent variable, so that's the thing that the researcher is manipulating, so what's being changed, and what are they actually measuring, so what's the dependent variable. Okay, so you should have found the IV, the thing that changes, that is the levels of arousal that they're changing by either getting the group to run on the spot for 2 minutes or 15 seconds. So that's what they're actually changing, whether they run for 2 minutes or whether they run on the spot for 15 seconds. And that would kind of be the representing the differing arousal levels. And then the dependent variable, what they're actually measuring was how attractive they found the woman in the video to be on a scale of 1 to 10. Okay, so that's the dependent variable. So the first thing that you need to look at is, has the criteria for the Mann Whitney U test been met? Yes or no? So again, you might want to pause the video now and just rewind it back to that scenario and just have another read through the scenario and try and look through or look for all the three criteria that we know it has to be, and almost highlight it or just spot it in that scenario. Okay, so yes, the criteria for the Mann Whitney U test has been met, and I would like you to write down the parts in the scenario that indicated the three criteria had been met. So you may have already jotted that down just now from the bit before, but you can quickly pause the video now and write that in if you haven't. So what you should have got was, yes, it was a Mann Whitney U, or it should be, because they were looking for a difference, and that was because it purely states they're looking for a difference between the arousal amounts, that's the running for 2 minutes or 15 seconds, and whether that had a difference in perceived attractiveness. So they were looking for a difference in arousal and attractiveness. They were using ordinal level data because they were asking the men to rate the attractiveness from a scale of 1 to 10 of attraction. So attraction itself is a very subjective thing. You know, people find different people attractive, and even then, is it fair to say on a scale of 1 to 10 those are going to be people's opinions? So it's definitely not factual. So it wouldn't be interval level. It would definitely be ordinal. It's very subjective. And there was independent groups because they had two groups of men, and each group of men were asked to run for either 2 minutes or 15 seconds. So they didn't both run. Both groups didn't run for 2 minutes, and both groups didn't then run for 15 seconds. You were either in group A running for 2 minutes or group B running for 15 seconds. So you were doing separate conditions, so it was independent groups. The next thing I want you to go back and write down, how many participants were there in each group? It's important to pick that out, especially for when we're using a Mann Whitney, because it's independent groups, and sometimes the amount of participants in each group won't be identical, because sometimes people drop out of experiments and there might be a couple less in one group than the other. It's important to know because we're going to need that information when we read the critical values table, because the critical values table for a Mann Whitney is slightly different to the ones that we've previously looked at, so you'll need that information later. So, the participants, group A, there were 10 men. Group A, when we come to look at the critical values table, will be referred to as NA. So if you remember, in all the other critical values tables, N represents number of participants, so NA simply represents number of participants in group A. So that's how it's written in the critical values table. And then group B had 14 participants, and that will be written as NB, so number of participants in group B. So make sure you write that down because we're going to need that information in a bit later on. Okay, so would the alternative hypothesis be one-tailed or two-tailed, and how would you decide this? So again, I want you to pause the video, go back to the initial description of the experiment scenario, and have a think about whether it would be one-tailed or two-tailed and how you would determine that to be the case. Okay, so hopefully you all got this. It should be one-tailed, and how you would decide that would be because there was previous research. So on the first introduction of that experiment, it said that previous research has indicated that there could be a link between arousal level and attractiveness levels. It just said that there's been previous research on that particular topic, so you would go for a one-tailed hypothesis. And again, you need that bit of information later on with the critical values. So here, this number, the results after the Mann-Whitney test came back as 16.5. This number has just been randomly generated by the test. So all of the other tests, I actually got you to calculate it. But for this one, we're going to do it backwards. So this is what the actual number was. So 16.5 is just the value of the Mann-Whitney test after they put all those data in and they worked out that that was the result. So we're going to go straight to working out if that result is significant or not. So this is why previously I've asked you to do the calculation, because if you got given 16.5 as a random figure in the exam, you might kind of be like, oh, where did that number come from? That doesn't really make sense. Where's that from? So this is why it might be confusing that I've suddenly just given you 16.5, but you just have to imagine that they've gone through that lengthy process of calculating the Mann-Whitney test by hand, and that was the result, so the calculated value. Okay, this is what a critical values table looks like for a Mann-Whitney U test. You will notice already that it looks very different to the critical values table that you've seen previously that you've used for Wilcoxon and chi-squared. So it's got this NA up here, and it's got NB, and it's got all these numbers, and it just says that this is a table for a one-tailed test. So it doesn't even give you the option for a two-tailed test. It's just said, we've used one-tailed, this is the critical values. So there actually will be a separate critical values table if they wanted you to use a two-tailed test. But because they've given you this one, we can assume that it's one-tailed. We already know that it's one-tailed because there was previous research, so it makes sense as to why they would give you this table. So the first thing you need to look at is this NA and NB. So again, you can rewind the video if you need to, but I did just mention that NA and NB, what that actually means. So why do we have NA and NB, and why is there two separate lines for both of them? So if you want to pause the video now and quickly rewind it and try and find out what NA and NB meant if you've forgotten. Okay, so NA is number of participants in group A. That's why I got you to write down the number of participants for each group. NB is number of participants for each group in group B. So in group A, I think there was 10 participants. So that's 10 in group A. And in group B, I think there was 14. So down here. So all you have to do is scroll across the same way that you would do with a normal critical value. So you scroll NA, number of participants in group A was 10, number of participants in group B is 14, you meet them in the middle and you should get 41. That is your critical value for a Mann-Whitney test, for a one-tailed test at that level of significance as well, which they've already done for you. The reason why there are two lines for the groups is obviously it's independent groups, and as I said, sometimes you might get differing numbers of groups, so that does have a large effect on the overall critical value and working out if it's significant, because what could happen is you might have 14 men that were doing the condition where they ran for 15 seconds, and you might actually only get 4 men because loads of them might have dropped out because they couldn't take part anymore or they didn't want to, that ran for 2 minutes. So then your critical value drastically drops from 41 to 11, because if you've got less participants, the less participants you have, the less likely you're going to find a significant difference, because it could have just been like coincidence, which is why we always say the more participants you have in a study, the better, because the more chances of you finding a genuine result, because otherwise, you know, if you just had one person, how do you know that that wasn't just fluke or coincidence? So the more times, the more people you get with a similar result, the more reliable and the more statistically significant it might appear, which is why with a higher number of participants in each group, you get a higher critical value. So the critical value for this particular one was 41. For a Mann-Whitney U test, the calculated value, that was our 16.5 that I just generated for you, or they did it for you, that must be less than or equal to the critical value in order for the results to be significant. So you've got 16.5, and if you go back here, you've got 41. So 16.5 has to be less than 41 to be significant, therefore it definitely is significant. But if you go back to what I just talked about with the lower participants, say if you did only have 4 participants in that group and maybe you had 6 in that group, you would end up with 3, and 16.5 is not less than 3, so then it wouldn't be significant. So you can see here that as the participants increase, the critical value numbers increase as well, so it actually increases the chances that you will find a significant difference. The less participants, the less likely the 16.5 value will be less than that. So that's kind of how they've done it. So yes, the results are significant because the calculated value, a Mann-Whitney test, just by if you're interested, is written as U equals, so that's the, you know, what, T or S or chi-squared, so that's U for Mann-Whitney U. 16.5 is less than 41, therefore the results are significant. Okay, nice and easy. And then you would just report and justify in the conclusion like you've done with the others. So yes, there was a significant difference, or you could say increase, as we're using our one-tailed hypothesis. So you would say, you know, as arousal level increases, the attractiveness rating also increased. So there was a difference between arousal levels and rating of attractiveness when using a one-tailed test at 0.05. And then you can also say when the number of participants in group A was 10 and the number in group B was 14. Therefore, we can accept the alternative hypothesis and we would reject the null. And then we can generally conclude that men find women more attractive when they're at a higher level of arousal, so when they were running for longer.